Okay, before we move to the new syllabus, I would like to cover this virtual link because the video which I'm uploading is not having some proper sync, and it will be fixed by today. Let me just finish with this virtual link for you. You see, the plan is to combine two areas. Where all area need to be connected to backbone area. Don't see this picture. I'm not talking on this picture. All area need to be connected to a backbone area. For some reason, this area 10 is not connected to area 0. This area 10 is not connected to area 0. What will be the problem? Problem is area 10 networks will not be given to any area. It won't be even given to area 1. Why? For the routes to go from one area to another, area 0 is needed. So what we do is we connect this area 10 to area 0 via a virtual connection. And this virtual connection we make between these border routers, which has got one border between area 0 and area 1. Another is between area 1 and area 10. If you will know the router ID of these two routers, you can do that. See, the router ID of router A is 10111. Router ID of router B is 110.222. So what I do, I go inside A and say area 1 will become a virtual link for me. The virtual link endpoint is 110.222. Likewise, we go to router B and say router OSPF 1000, area 1 will be a virtual link for me. The virtual link endpoint is 10.111. That's all. So the negotiation comes from 10.111, which is matching here, and the negotiation comes from here 110.222, which is matching here. So they form a tunnel. So B will feel that it has got connection to area 0. Thus, this becomes an ABR. Without area 0, no router can be called as an ABR. Now, router B has got a connection to area 0, and it is ABR now. You see? So, any question? So, area 10 route will be now given to area 0 via the virtual link. And from area 0, it will be given to area 1. Same way, area 1 route will be given to area 0, and then from area 0, it will go to area 10. Right? That is how it is. After this, we saw OSPF LSA types. We have finished from 1 to 5. As of now, we are going to learn only 1 to 5, and which we have finished with the demo. 7 we will be seeing later when we learn a topic called stub. The stub is not EIGRP stub, this is OSPF stub. Okay, now What about type 6? In the multicast environment, when you run OSPF, see, you have OSPF in a normal topology that you already have. In that normal topology, if you will also enable multicasting, then multicasting related informations need to be distributed between the OSPF running router. For that, you need this. You are not going to do any configuration, it is automatically taken care. Same way, when you are enabling BGP on the same router where you already have OSPF, and when you redistribute BGP routes into OSPF, this particular attribute, sorry, LSA type 8 comes into picture. Finally, you see this 9, 10, and 11, they are put in one opaque LSA, meaning they are available for extension. They are available for you to use it for future enhancement. That's how it was kept initially, but now it is used in various places. Actually, we see these 9, 10, 11 is used with IPv6, with segment routing, and so on. So what is need to be worried is type 7, which we will see later. And type 5, 1 to 5, you have already learned, so you don't need to worry. You already know what it is. You don't need to care about it now. If you have any question, you can ask that question on 1, 2, 3, 4, and 5. Anyone has got any question on LSA type 1, 2, 3, 4, 5? When we did the lab on LSA types, I was repeatedly using this command show IPOS database. You see, we have router LSA of area 0, network LSA. Network LSA is what in short written as net. Network LSA. So there is only one DR in this topology. So the sample output shows that there's only one designated router. And the router ID of the designated router is summary LSA is an LSA comes from another area. This router is in area 0. These routes are not of area 0. These routes are from some other area like 1, 2, 3. Summary LSA. You see, in the routing tables, you might have noticed, even I showed you repeatedly, we know the meaning of these things. We have already seen in the lab. In the routing table, you have only O. It means the routes are from same area. Intra. OIA is there in the routing table, which means they are coming from other area. And which LSA is bringing it? Type 3 LSA. Anyone has got any question on this one? I'm saying type 3 LSA. Do you all convinced? Type 3 LSA routes will be seen with IA or with IA. Anyone has got any doubt in that? Type 5. Inter area, I'm talking about other area. Okay. Type 3, okay? Type 3. Next. The external routes will be E2 by default And this is not LSA type, this is external type 2. This is default. No calculation of path cost. And the routes are external routes, not the same autonomous system. It is outside the autonomous system. And it is type 5, the one which brings it. Type 5 only brings it. And when it enters, the metrics are not, path metrics are not added by default, that is E2. But when I say metric type 1, then it becomes E1 for the same type 5. All right. So type 5 LSA informations are E2 and E1. In T5, in type 5, if you switch that E to E1, from E2 to E1, path cost will be added. If not, path cost will be whatever that has been given during the redistribution time. Anyone has got any question on this? Let me explain you again. You see here in this picture, this is OSPF autonomous system. And this is another autonomous system. Routes are coming from here. While redistributing, if you don't give metric, what is the default metric? 20. But here, they are giving a metric, 1785. The default is E2, that 1785 is even seen in R5. No change in the metric. Whatever is given during the redistribution is maintained. Even in R3 it is the same, R5 also it is the same cost to reach the external networks. But when you change to E1, 10 gets added and you get 95. Another 20 gets added, you get 18, 15 on router 5. 10 plus 10 plus 10 is 30. When you add 30 to this, you get 18.5. Path cost is added. We did an exercise on this. So here route shows some networks are connected, ignore them. Some have got OIA, meaning these two are coming from another area. This is coming from same area, this is coming from same area. And this is coming from another autonomous system. This is type 5 brings it. These two type 3 brings it. This and this, who brings it? Type 1 and type 2. Type 1 and 2 is what? O. Within the same area. They don't cross the border. Type 3, summary LSA coming from other area. Type 5, external autonomous system LSA coming from another autonomous system. I don't know how many are using this, but it is good to know once. We have an option to reduce the amount of LSAs that will be flooded from one router to another. See, if your bandwidth is too limited, you don't have enough bandwidth. கல்யாணத்துல விருந்தினர்கள் சாப்பிட்றதுக்கு அந்த வெட்டிங் ஹாலில் பார்த்தீங்கன்னா ரொம்ப சின்ன ஸ்பேஸ் தான் இருந்தது சாப்பிட்ற இடம். விருந்தினர்களே வந்து போறதுக்கு கொஞ்சம் கஷ்டமா இருக்குது. இதுல 100 எம்ப்ளாயியை வச்சு நீங்க சோறு டிஸ்ட்ரிபியூட் பண்ணீங்கன்னா எப்படி அது கஷ்டம். வந்தவன் எல்லாம் திட்டிட்டு போவான். எங்கப்பா அங்க இடம் இருந்துச்சு, உட்கார்த்து கூட இடம், நிக்கிறது கூட இடம் இல்லை. அவங்க ஆளுங்களே இந்த கேட்டரிங் ஆளுங்களே ஃபுல்லா எங்க பார்த்தாலும் சிட்டிஸ்ல அந்த மாதிரி மேரேஜ் ஆள் நிறைய இருக்கு. So if you will have a network like that, very less bandwidth between routers, and if LSAs are too much occupying the bandwidth, then where will be the space for user traffic? So it is not only occupying the space, it is also going to consume a lot of CPU, more the LSAs, more CPUs. The CPU have to see what is there in LSA. Is there any new thing in the LSA? Is the sequence number same or not? If it is different, it is higher or not. This all takes process. That is what here it is saying. No nice word it is used. Excessive LSA generated by other router can drain local router resources. So by using this max LSA command, this feature can limit the processing. Sorry. Okay, if excessive LSA, it can limit the processing of non-self-generated LSA for defining. Okay, correctly. So by using this max LSA, you can limit the LSAs coming from other device. Non-self-generated means what? Generated by someone else, someone. It's not self-generated. LSA coming from other router may drain the resources of this router. So in this router, which has got limited resource, what you can say, I will accept only these many percentage of Mac. LSA cannot go more than like 2% of the bandwidth. If it goes, what to do? If it goes, send a warning. Or keep ignoring all the LSAs from this time for this many minutes so that it will go down. Right? Or ignore this many number of LSAs. No one will reset after something. Okay, anyway, what I'm trying to say is this feature, first of all, I have not seen people using it. But if there is a situation, a customer is having a very old router, only one router, very old, and that is in one corner, which couldn't handle the amount of LSAs that are coming, you may enable this under OSPF process. Any question on this? Okay, we are going to see something very important in the next page. What is the metric of OSPF? Can anyone say? Cost is the metric of OSPF. When I heard this in my CCNA, unfortunately, they did not stretch much, saying cost is calculated based on bandwidth or nothing. They said cost, 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 cost. I know cost in dirhams, in franc, in rupees, dollar, real. So I was confused which cost they are talking about. Omani Riyal or Saudi Riyal? What Riyal? I was confused. Then later I found the cost is a numerical value that you and I can set for each link. So that OSPF will decide on the path by calculating the cost that we feed. And if you don't feed the cost, if you don't set the cost, it will auto calculate the cost using bandwidth. Yeah? Yes. Most of the people who knows OSPF, they focus only on the auto calculated cost. Auto cost. Auto cost. We don't focus on the cost that we can give manually. See, we can give cost manually by going under each wire, each port, and say IP OSPF cost and give a number. You can give the cost. For example, I have two routes to reach from alpha to epsilon. I have two routes to reach, and I want OSPF to choose this route. So what I'll do, I'll go manually give cost 10, 10, 10, 100, 100, 100. That's it. Now the path taken from alpha to epsilon is as per my policy. 30 is cheaper than 300. Yep. So alpha to epsilon, it's going to go via the upper path, not the below path. You can go to each interface here and set that cost 10, 10, 10, 10, 10, 10. And this is the command IP OSPF cost, blah, blah. But most of the people don't do that. Mostly people will leave default. OSPF itself will calculate it automatically. When you give a cost, that automatic calculation will be overridden. So for what more importance OSPF give it, no? It don't give to auto cost, automatically calculated cost. It gives importance to what you dictate as a cost. Okay, now let's see how the auto cost works. How the cost is automatically calculated. Let me draw this picture here. Oh no. Let us say this is Ethernet and this is fast Ethernet. Can anyone say the speed of Ethernet? What is the speed of Ethernet? 10 meg only. 10 meg. What is the speed of fast Ethernet? Can anyone say? 100 meg. Century அடிக்கிறது நம்ம ஆளுங்க சூப்பர். Say 100. Right. Now let's see how OSPF calculates. Cost is equal to 100 by 100 is called as what, you know? Reference bandwidth. Reference bandwidth. 100 by actual bandwidth over the link. Link's bandwidth. Okay, this is the formula. Cost is equal to 100 by bandwidth on the link. Now let's see for this link. Cost is equal to 100 by 10. What is the answer? You get 10. So cost on that link here is 10, 10, 10. Now let us do for the below path. Cost is equal to 100 by 100, isn't it? You have 100 here. What is the answer? What is the answer? One hundred by 100 is what? 0? Unmute பண்ணிட்டு mute பண்ணிக்கிறாங்க. பதிலே வரல காது. 1. Okay. So 1 here, 1 here, 1 here. So to go from A to B via alpha is only 3. Via beta, it is 30. So definitely the path taken is going to be this. You see, this is how by default the best path is determined. More the bandwidth, less the cost. You understood, no? This is total cost, TC. TC naale 10th standard la bhayapuduvanga. Here total cost is 3 only. Here it is 30. So lower the cost, better is the route. So traffic will go from A to B via alpha. That is what here mentioned. Okay. Now let's see the command to change this. Change what? Change this reference bandwidth. I told you the bandwidth that you write on the top is called as what? Reference bandwidth. If you wish to change this value, you can change it. Why to change it? We'll see. Give me 2-3 minutes. But how to change it is what mentioned here. By default, it is 100. If you have a plan of changing it for a genuine reason, we can do it by using this command. I can say auto cost reference bandwidth 1000. Instead of 100, I can say what? 1000. So this will become 1000 here. I can say 10,000 also, so that this will become 10,000. All right. If you wish to change the default algorithm, which is used in calculating the cost. You may use this auto cost reference bandwidth command. All right. Now, I'm going to explain you in what situation you may need, or you need. It depends. You may need or you need to change this. Okay. The scenario is this. The speed of this link is 1000 meg because you got a gig wire, gigabit, gig ethernet, gig ethernet, gig ethernet, 1000, 1000. Now let's go to the original formula. What is the original formula? Cost is equal to 100 by the actual bandwidth on the link. So let's see, 100 by 1000. What is the value you will get? See, for metric and all, you cannot have fraction numbers. So it is equal to 1 only. You got it? 1 only. Cost is 1. Now, according to OSPF here, what it thinks, it thinks both the paths have equal metric. 1 plus 1 plus 1. Not correct, no. Not good, no. Cannot be accepted. OSPF thinks both have got same metric. It is because of this numerator only. See, OSPF is very old according to networking age. Network age, 5 year itself is old only. 5 year before, you are not having 4G also. Today you have 5G. 5 year before, your telephone network was having 3G. I don't think so. I think 2G. Your cell phone was running in 2G. And today you have 5G. Just 5 year itself, But OSPF is, even before I started my networking, even before my days. I started in 2006. In fact, 2005, when I was in MCA, I submitted a paper on the final year, network border patrol. Network border patrol. I was using OSPF as an example there. That was my paper presentation. Network border patrol was my, not final year project, it was my, I think, second year project in my master's degree. So this OSPF is very old protocol, you see. Later you can Google and check how old it is. But what I'm trying to say is, on those days, 100 meg and all, dream only. You can dream only. நான் போய் இதை என்னத்துக்கு ட்ரீம் பண்றேன்? நான் ஒரு பங்களா கிடைக்குமா, கார் கிடைக்கும் ட்ரீம் பண்ணுவேன். வாஸ்தவம் தான், இதெல்லாம் ட்ரீம் பண்ணாதீங்க, வேஸ்ட். Anyway, 100 meg என்றால் no one will even think that we can achieve on those days when OSPF was made as a industry standard routing protocol. No one could imagine that we will have 100 meg bandwidth. But today we have 100 gig bandwidth. You know that 100 gig bandwidth wire is there, 40 gig bandwidth wire is there, 10 gig bandwidth wire is there, 1 gig is there. I remember in 2006 when I bought my first computer. No, 2005 when I bought my first 2004, yeah. When I was in first year of MCA, about 2003. When I bought my first computer, there was one internet connection from BSNL. BSNL was the only network. Reliance and all came now only. Now means after that only. Only BSNL was there, and they charge heavily. For every second they will charge. And also they will come and install one software in your computer, one dialer. With the phone number only we dial. With phone number, phone connection wire only. It was a analog internet. So through dialer, we will double click on the desktop and a button will come, dial. Click the dial button, it will make one sound. When we get that word, we will be very happy. It's connecting. When it is, we are worried. Connect connect. And when you try to open one web page, and those days no Google, some search engine was there. When you try to open, it will take many minutes to open one page. Not even big graphics on those days, only static pages. Static page to open itself, it will take many minutes. And this browsing center, people are not very happy. வந்து 2 பேஜை பார்த்துட்டு 50 ரூபா கொடுத்துட்டு போவான். அப்படி 2 பேஜ் தான் அவனால பார்க்க முடியும். உங்க ரெகுஷி 50 ரூபா ஒரு மணி நேரத்துக்கு கொடுத்துட்டு போவான். That was the day when OSPF was initially standardized. So formula was 100. இதுவே நம்ம எட்ட மாட்டோம், எட்டா கனியா இருக்குது, தொலை தூரத்துல இருக்கிற ஒரு எட்டாத கனியா இருக்குது அப்படின்னு நினைச்சு இதை வந்து அப்பர் லிமிட்டா ஃபிக்ஸ் பண்ணாங்க. ஆனா இன்னைக்கு எங்கேயோ போயிட்டோம். So if you really want to differentiate this bandwidth and give proper auto cost, what you have to do is you have to change this numerator value. If I change the numerator value to 10,000 to 10,000, the cost is going to be, the bandwidth is 1,000 here, the cost is going to be 10, 10, 10, 10, 10. And for this, it is going to be 100, no, the below path, 20 you cut. So the cost is going to be 100. So all traffic now will go via gig Ethernet path, not via the fast Ethernet. You see, if you want to justify, if you want to do the right thing, to choose path only via the path with more bandwidth. By default, the OSPF don't have visibility because of the numerator 100. But when you change the numerator to 10,000 or 1,000 or 10,000, now you have the visibility. அது gig ethernet, இதுக்கு fast ethernet. இதுக்கு ரெண்டுத்துக்கு நம்ம ஒரே கொடுக்க முடியாது. நல்லா கண்ணை திறந்து கால்குலேட் பண்ணுவோம் அப்படின்னு சொல்லி கால்குலேட் பண்ணி gig ethernet வழியா போலாம். அது வழியா போனா எவ்வளவு fast? We'll go via gig ethernet. What is the cost? 30. If you go via fast ethernet, it is 300. So gig ethernet is the best path. You see, only when you have in your topology gig ethernet or more than 1000. If you have gig or 10 gig or 40 gig or 100 gig links, that is the scenario where you need this command to change the numerator value. Any question from anyone? You don't have any question? No questions from anyone? In this chapter, we focused on types of LSAs. That is very important. Type 1 router LSA, network LSA, type 2, type 3 and 4, summary LSA, type 5 external LSA. And then we saw the difference between E1, E2. And then we saw how to protect from overload of LSA. And then we also saw when we have different bandwidth links, 100 meg, 1000 meg, 10,000 meg links, we need to change that classical formula in the OSPF which calculates automatic cost. For that, the cost, the numerator value in that cost formula can be changed by going under OSPF and say auto cost reference bandwidth. What? Auto cost reference bandwidth, and then the value that you want to set. And if you want to have your own cost, you don't want to rely on the auto cost. Bandwidth எல்லாம் பார்க்க முடியாது பாப்பா. நான் சொல்ற மாதிரி பாதையை அதை தேர்ந்தெடுக்கணும். ஏன் ரவுட்டர், ஏன் ஒரு ரவுட்டிங் ப்ரோட்டோகால், அது என்ன அதுவா ஏதாவது ஒரு பாதை எடுக்கிறது, நான் சொல்ற மாதிரி தான் போகணும் அப்படின்னு நீங்க நினைச்சீங்கன்னா, you have an option. This is the command. Go to each port in the path, set the cost. Small cost you give, more preference given to that path. Right? So we'll stop here. We'll meet again in another chapter of OSPF. See you.